Hello everybody, and once again welcome to Pankaj's Echelon Tutorials. And this is another session on IGCSE curriculum, and the subject is again your international mathematics. So it is IGCSE curriculum, and subject is international mathematics. And the topic is I was telling you that in the last video, I told you that I'll be explaining you a test. The questions in the test I'll be explaining you. So in the last video, I explained you two questions, question number 5 and question number 6. Okay. So now we are going to continue the same thing. And we are today now going to solve this question number 7 and 8. Okay. So welcome, and let us get started with the question number 7 over here on the test paper. Question number 7. Now what question number 7 has to say is, there's this diagram given. This diagram is pertaining to question number 7, right? So you can see that there is a diagram which shows two rectangles, okay, one inside another, right? So in the diagram, this particular diagram, they say that the ABCD and EFGH are two rectangles. So if you see carefully, this ABCD is a outer rectangle, and DEFH, okay, is the inner rectangle. And the dimensions given are AB is equal to 10 centimeter. So this is 10 centimeter, right? And your AB is 10 centimeter, BC is 7 centimeter, this is 7 centimeter. And then again EF is 7 centimeter, so this is also 7 centimeter. Okay, this EF is 7 centimeter, and this GH, okay, sorry, FG is given as 4 centimeter, so this is 4 centimeter, right? So these are the two rectangles with the dimensions over here. Further, he says that all this length, that is 10 centimeter, 7 centimeter, 7 centimeter, 4 centimeter, these dimensions are accurate to the nearest centimeter. Okay, so the dimensions of the rectangles are correct to the nearest centimeter. Okay, now this is something known as accuracy. So accuracy is given as nearest centimeter, nearest 1 centimeter you can say, or just nearest centimeter, right? Now what you have to do is, the question here is find the largest possible value of the shaded area. Now this pink shaded area is given to you, right? That is the area between the outer rectangle and the inner rectangle. That pink shaded area you will have to find out and tell the maximum possible value of this shaded area, or you have to say the largest value of the shaded area, isn't it? This is what they have asked you. So how we are going to deal with this question? So what you have to do is, in this question, these dimensions that are given to you, now first we'll take the outer rectangle, right? So outer rectangle may, the length is given as 10 centimeter and the width is given as 7 centimeter, right? So this 10 centimeter ka, we will find out the upper and the lower bound. So on this side, I'll take 11 and here I'll take 9. Okay. And this will be the midpoint of this. So this will be 10.5 and this will be 9.5. Okay. So this is the upper bound and this is the lower bound, right? For this 10, the length. Okay. Similarly for 7, you'll take here 8, you'll take here 6. And you'll take the midpoint of this. So this will be 7.5 and this will be 6.5. This is the upper bound and this is the lower bound, right? So you have got the upper bound and the lower bound of these two sides of the rectangle, the outer rectangle, 10 and 7. Now, the largest value of the shaded area means what? There is one more rectangle inside this rectangle, okay? That is a smaller one, okay? Now, this rectangle has the dimensions, this is 7 and this is 4. So again, for this also, for this 7, the lower and the upper bound will be same, like this only, 7.5 and 6.5. But for 4, this width, the upper bound and the lower bound will be, here you'll have to take 5, here you'll have to take 3, and this will be the midpoint. So this will be 4.5, which is the upper bound, and this should be 3.5, which is the lower bound. Okay. So now that you have got all the upper bound and the lower bound of all the 4 dimensions, okay, now what you have to do, you should try to find out the largest value of the shaded area. Now shaded area is when you put this rectangle inside this bigger rectangle, okay. Then whatever this area is given, this shaded area, this area you want to find out. So this shaded area will be area of bigger rectangle minus area of smaller rectangle, isn't it? This should be the answer, right? Now this value to be largest, what we'll do, the area of the bigger rectangle should be largest. So for the area of the bigger rectangle to be largest, okay, that is the outer rectangle, you will have to take the upper bounds of 7 and 10. So area of the bigger rectangle, you will have to take 10.5 times 7.5, isn't it? This will make the area bigger, okay. And the smaller area of the area of the smaller rectangle, you will have to take lower bound, because if you take lower bound, the quantity will be still lesser. So lower bound you will take for the dimensions of the inner triangle. So for 7 and 4, the lower bound will be 6.5 multiplied by 3.5, isn't it? Now this value will give you, this will be biggest value of the outer triangle and this will be the smaller value of the inner triangle. This way you will get the largest difference in the two area. That means the largest value of the shaded area you will get. If you work out this, let us see what you get. 10.5 into 7.5 minus 6.5 into 3.5. So let me do that. 10.5 times 7.5, I'm getting as 78.75. Okay, so 78.75 minus, now this will be 6.5 times 3.5, right? That I am getting as 22.75. 22.75. So my final answer should be 78.75 minus 22.75, which works out to 56. This works out to 56. So this 56 centimeter square is nothing but the largest value of the shaded area. And this is the answer for this question number 7. Okay, so we are done with question number 7. Now let us come to question number 8. Now question number 8 says that, okay, I'll bring down the question for you. Yeah, that's enough. Chalo. So question number 8. Question number 8 is saying that, it's over here. It says that when the voltage V is applied to a resistance R, the power consumption P is given by, so there is a relation given between the power and the voltage and the resistance. So this is the relation, power is equal to voltage square upon the resistance. Okay, so this is a concept of physics where according to Ohm's law, when you modify the Ohm's law further, you'll get power is equal to V square upon R. P is the power, V is the voltage, and R is the resistance. Okay, so this is the formula which you have to use. Now he says that if you measure voltage as 12.2, so voltage is taken as 12.2 and the resistance is taken as 2.6. They have got these values 2.6. Okay, voltage is 12.2, resistance is 2.6, and these two values are correct to 1 dp. Now when you say correct to 1 dp means 0.1. Okay, so this is the accuracy given, correct to 1 dp. Okay, 1 dp means 0.1, right? Now they have asked you calculate the smallest possible value of P. Smallest value of P. So they want this P value to be smallest. So P to be smallest, okay, to P to be minimum, your V should be what? It should be minimum, right? And your R should be minimum, okay? Your V should be minimum and your R should also be minimum. Am I right? So, okay. No, your V should be maximum, okay, not minimum. This should be maximum and your R should be minimum, okay. If V is maximum and R is minimum, or let me not put arrows, I'll just explain you the other way, right? Okay, I don't want to put these arrows, it will give you a wrong signal. See, P is equal to V square upon R is the formula, right? Now, suppose I tell you 25 upon 5. What is the answer? It is 5. 20 upon 5 is 5, right? Now, if I want this to be more, okay, this value, if I want to be more, what I will do, I will reduce the, I will reduce this value, okay. I will increase this value. So 5 है ना, so I will make it something more than 5. So say I will make it 10, okay. And this value, okay, I will this value I will increase. So suppose I make it 50. Now 50 upon 10 is 5. So what I am getting? The answer same as 5. Now what I did here, here I doubled it. Here also I doubled it. So both the sides I doubled it. That means I did nothing over here. And that is why I am getting 5. But suppose if I want the smallest value or this value of P I want smaller, then what I'll have to do? This value, V value, I will have to see it's like this numerator upon denominator. This is a fraction. Now, this numerator upon denominator is always greater than 1 if your numerator is greater than denominator. Okay. So, if numerator becomes bigger and the denominator becomes smaller, right, then the ratio will become bigger. This is how we can understand. If the numerator becomes bigger and the denominator becomes smaller, then the ratio becomes bigger, right? But if you want to make the ratio as smaller, what you will do, this denominator you will have to increase and the numerator you will have to decrease. Okay, this way you can understand, right? So here V I will have to decrease and R I will have to increase to make this particular value smaller, isn't it? So what I mean by decrease and increase, by decrease I mean lower bound, by increase I mean upper bound. Okay. So let us take the upper bound and lower bound of this 12.2. So 12.2 ka upper bound and lower bound will be what? Now this is correct to 1 dp, that is 0.1, isn't it? So 0.1, 0.1 I'll write here. Now what is half of 0.1? It will be 0.05. This will be 0.05. So my upper bound will be 12.2 plus 0.05. That makes it 12.25. So this is the upper bound. Similarly, my lower bound will be 12.2 minus a 0.05. That will make it 10 minus 5 is 5, 1. So 12.50. So this is my lower bound. This is my upper bound. Okay. For this 12.2, that is voltage. Similarly for R, let me find out for R. Now R value is what? It is 2.6. So for 2.6 also, I will find out the upper and the lower bound. So this is halfway of 0.1, that is 0.05, 0.05. Now this will be added, this will be subtracted. So my upper bound for 2.6 will be 2.6 plus 0.05. That makes it 2.65. So this is the upper bound and the lower bound will be 2.6 minus 0.05. 10 minus 5 is 5 and 5 over here. So 2.55. This is the lower bound. Now, to have this p value smaller, okay, my v should be what I told you is written here. Okay, for p to be smaller, my v should be smaller and r should be bigger. So for v, I will take the lower bound. Okay, v square upon r. So for v, I'll take the lower bound. So lower bound for v is how much? 12.15. So I'll take 12.15 square. And for r, I'm going to take higher value. That is upper bound. So upper bound for 2.6 is 2.65. So this has to be my answer. Now let us calculate the answer and see what we are getting. So the p value to be smaller, okay, he has asked you, okay, calculate the smallest possible value. So you have to calculate this value p. So it will be 12.5 squared divided by a 2.65, right? And that you are getting as 58.96. Am I right? Uh, 1 second. Huh? No, it's 55.7. 12.15 upon 2 point lower bound I have to take, right? Some mistake over here, lower bound. Lower bound will be 2.6 minus 0.05. So this will be 10 minus 5 will be 5. This will be 5. Yeah, 2.55 is correct. This should be 2 point. This I have to take what? Okay. This R also I will have to take, I think R also I'll have to take, no, 2.65 only. So 2.15 upon 2.65 is correct. So I think there's some mistake over here. I'll recalculate it. 12.15 square equal to divided by 2.65, right, is equal to I'm not getting the answer. 12 point, yeah, 55.7 you should get the answer. Okay, 12.15 the whole square upon 2.65, right. uh, this is correct. Let me check it again. 12.15 squared divided by 2.65, and that is equal to, yeah, 55.7 I'm getting. This I'm getting 55.7. This is the value of that p. Okay, so this is the smallest value of p. So this is the right answer, 55.7. Okay, so this is how you have to do the problems based on upper bound and lower bound. I suppose by working out these 4 problems, 5, 6, 7 and 8, okay, I think you must have got a clarity of how lower bound and upper bounds are actually used to find out the smaller value or the largest value of a sum or a difference or a product or a quotient. In this case, it was quotient, isn't it? So, with this, we have completed question number 7, question number 8 as well. Okay, and this particular test may you have a second part, that is these questions that you have to do. Now, this part of the test, we'll be doing in the next session. So, this session I'm ending here only, and in the next session we'll be starting from this particular part of the test, that is pertaining to something called estimation. Okay, so you have to estimate the values of this things which is given over here. That will be doing the next video. So till then, goodbye, take care all of you, and if you happen to like my video, please subscribe my channel so that I'm motivated to make more and more videos like this. Okay, so bye, take care all of you, see you.